Hi everyone, Krishna this side. In this video, I'll be covering this LeetCode problem 2040, kth smallest product of two sorted arrays. So let's see what is the problem statement given to us. Given two sorted zero index integers arrays nums1 and nums2 as well as an integer k, we have to return the kth smallest product between these nums of I cross nums of j, where I is basically less than this nums1 dot length and j is basically less than this nums2 of length. Okay. So if we have these inputs, if we multiply this 2 with 3 and 4, these are the products that we can get 6 and 8. If we multiply this 5 with these two numbers, the products will be like 15 and it is going to be 20. So second smallest is going to be obviously 8, because whatever the values that we multiply with 5 and these two numbers, they are basically higher than this 8 value, right? So that is like, this is the second smallest product that we can get. Okay, so idea is clear for us, like what problem is basically saying, and these numbers are basically ranging from minus negative values as well as they are zero as well as positive values. Okay, all the numbers that are lying in this one. So the first basic idea that comes in our mind is like, okay, let's try to multiply all the possibilities that we can get it, and through that, either we can collect these all the answers somewhere, or let's use priority queue, where we can fill at most k elements in that into that priority queue, and at the last, whatever the answer that we get in the priority queue at the top, that is going to be the fifth smallest product that we can get it, right? So in this one, like, we are traversing across all the entire arrays, and it is going to be n square, sorry, it is going to be n cross m. Okay, if let us suppose this nums1 length is n and nums2 length is m, so it is going to be n cross m, because we are trying to do all the possibilities. But the problem is, in the constraint, if we see, the range is basically 500 into the power of 4. So if we try to do that, definitely we're going to hit TLE. Okay, so of course it is like 5 into 10 to the power of 4 is basically, again, if we try to multiply both of them, if at max all the elements are basically there, so it is like 10 to the power of 8 into 25, so which is basically big, and we should at least try to get the complexity in n log n. Okay, in log n cross n is also acceptable. Okay, so yes, that is something what we have to try, we actually have to figure out. So how we can get it? The first thing that we saw in the question is like, the numbers are basically in a sorted order. Okay. Okay. So okay, if at any point in time, if we are saying that the numbers are basically sorted or something like that, we at least try to see if we can apply binary search in that arrays. Okay. So yes, binary search, we will try to see how we can solve this particular question with the help of binary search. So let me just connect. Yeah, I hope the screen is visible to all of you. So here, if we see, this is the first array that we have. Okay, and this is the second array, and we are supposed to find sixth smallest product between these two arrays. Okay, so if we try to get the range, what could be the range between these two numbers, the maximum and minimum product, that is something what we have to get. So if we try to get the maximum product, obviously whatever the values that are there in the last, if we multiply them, it is going to be the maximum product. Any product that is beyond this 16, if we try to get it from this array, we cannot achieve it, right? Okay, so we cannot achieve it, because see, even if negative values are there, let us suppose -4 is there and -3, if we multiply, it is going to be 12. Okay, it is not beyond this 6. So maximum range is something what we have to figure out. Again, the minimum range that we can get it between these arrays. Okay, so minimum range could be whatever the minimum value, if values are basically in a negative, so minimum negative value and the maximum positive value, if we take, obviously between these two arrays, whatever the product that is we get, that is going to be the lowest range that we can get it. Okay, the lowest product that we can get it. So -16 and 16, this is the range that we have. In this range only, all the arrays product, different products that we can try, those ranges, those products basically rely, right? So let's just tell me, like, if we try to multiply any two numbers, right? If we try to multiply any two numbers, do we have any possibility that the answer could be less than this 16 or greater than this 16? We don't have any possibilities, right? So answer basically relies in this range only, -16 to 16. Okay, so any two arrays product, if we try to get, the answer basically relies in this one only. Okay, that is clarity that we have. Okay, now what we can try out is, like, we will try to see whatever the binary search logic that we will, what we wanted to apply, we will try to apply in this one. Okay, whatever the range that we got, right? So -16 to 16 is the range that we got. Okay, by multiplying uh, uh by trying to get the minimum and maximum product. We got this range. From this range we will try to get the answer. Okay, because the answer basically relies in this range only. That is clear for us, right? What we will try to say is, we will try to apply binary search logic in this one. So what we will do, whatever the range that we have, minus 16 and 16, so low should point right over here. Okay, and the high should point right over here. Okay, between this low and high, whatever the medium that we get, midpoint, so basically here is 0. So we will try to see if this 6, if this 0 is basically answer or not. Okay, the answer is basically whatever the answer that we are trying to see, it should be the kth smallest one. Okay, we will try to see this 0 is basically sixth smallest product or not. Okay, that is the question that we are trying to figure out, right? So in this range only, the answer is basically relying minus 16 to 16. So the question is like, whatever the medium, that midpoint or median, okay, that value that we get, basically we will try to see if it is the sixth smallest uh, product or not. Okay, it is the sixth smallest product or not. That is something what we will try to figure out. If to get that product, right? So okay, again, to get this product, we have to multiply all the numbers again, right? And we have to see how many numbers in terms of product. Okay, whenever we try to multiply all these values, how many products that are basically less than or equal to this 0. Okay, that basically tells, like, okay, from minus 16 to 0, there are these many numbers which basically having product 0 or less than 0. Okay, what I'm trying to say is, when I multiply minus 4 with 1, okay, the answer is basically minus 4. When we multiply minus 2 with this 4, okay, the answer is basically minus 8. So minus 4, minus 8, and all the different possibilities with the zeros, if we try to multiply this entire array, basically the answer is basically 0. So we will try to figure out how many total products that are there, basically the count in other terms, how many counts that are there which having product less than this 0. Okay, the question is clear. Okay, so yes, we will try to see how many total counts that are there which is having product less than this 0 or equals to 0. Okay, that way only we will get to know that whether this 0 is basically relying in this range. Okay, sixth smallest product is something what we are basically trying to figure out. So let us suppose at 0, by multiplying all the different possibilities product in terms of counts, total counts are, let us suppose, 12. In total counts, 12 possibilities that are there which is having product less than or equals to this 0. So obviously the answer, whatever the answer that we are trying to figure out, basically that is relying in this range. Correct. So when we tried multiplying all the different numbers with these numbers, okay, in the numbers also we will try to apply binary search logic. But first thing that we are trying to figure out is this for 0, okay, how many products that are there by multiplying these nums of array 1 and nums of array 2, how many numbers that are there, the count basically. When we multiply both the numbers from this product, from this nums 1 and nums 2, how many products that are there which is having value less than or equals to this 0. So if we found 12 pairs, let us suppose 12 pairs. So if 12 pairs that are there which is having product less than or equals to 0, definitely the answer is basically relying in this range. Okay, the answer could be anything. Okay, first thing is like we figured out how many counts that are there less than this 0. If let us suppose here the count instead of 12, if we tried seeing like how many counts that are there, total 4 counts is something what we got. Okay, less than or equals to this 0, total 4 counts. Okay, just we are assuming it. So if we got 4 counts, definitely the answer basically relies in this range, because so far till 0 we got 4 counts. So any numbers product when we try to do, okay, between these two numbers different arrays, okay, and total counts 4 counts is something what we got below this or less than or equals to this 0, the answer could be relying in this range. So what we can do, low basically simply points this 0 plus 1, and high in the case of like value whatever the count that we are trying to see, if less than or equals to 0, the high is basically whatever this count that we are getting. If it is less, let us suppose 12 was there, so obviously the high should point here. Okay, so we will try to shift the ranges, and in between that ranges we will again try to see the counts, total counts. Okay, that was the basic idea that we have right over here. Okay, the first step is clear to all of us. Let's try to see next steps. Okay, so let me clean up this all the mess that I have created right over here. And now we are basically trying to figure out how many products basically less than or equal to this 0 from this between these two arrays. Okay, so first thing that we will do is we will go through this entire array, at least one of the array between these two arrays that we have. We should go to from this array entirely, because that way only we will get the counts. Okay, but with this second array, whatever the second array that we have, with this one we can at least with the help of binary search we can get the counts. Okay, we are not required to go entirely in this particular array. Okay, so that is something what we will try to see, like how we can do it. Okay, so first thing is like from this first array any one of them we can pick, and that should be constant. So this particular first array is something, let us suppose I picked. Okay, and we started from this 0th index. We will try to see when we multiply this 0th index with this entire arrays. Okay, how many values that are basically less than or equals to 0. Okay, that way only we will get to know like the counts. Okay, because we are basically trying to figure out this is the target for us, and below this or equal to this target, how many products that are available by multiplying between this nums of 1 and nums of 2. Okay, so yes, the numbers could be either 0 or positive or negative. So three different operations will be there, because see, when we multiply negative cross negative, definitely it will be positive. When we multiply negative with positive, it will be negative answer. Okay, yes, different answers we will get. Okay, if numbers are different, if numbers are basically in increasing order and greater than 0, obviously we wouldn't have even tried all this different methods. Right? Directly we would have tried applying the binary search on those numbers only. But yes, in this particular case we have to get three different, we will basically get three different possibilities. Okay, so the first is like 0. Let us suppose if number in this particular array, because we are traversing in this particular array, if the number is basically 0, if the number is 0, in that particular case whenever we multiply 0 with any number, the answer is basically going to be 0. Okay, so if our target, whatever the target that we are having, if the target is basically greater than or equals to this 0, whatever the target that is there, if this target is actually greater than or equals to 0, in that case all the counts that we get, because this multiplying 0 with any numbers is basically 0, all the counts that we get we have to consider them. So when we multiply this 0 with this all the numbers, let us suppose its length is n2, its length is n1, how many numbers that we get? N2. In total the count is basically, count is something what we are updating, like how many products that are there which are less than or equals to this given target. Okay, initially count is basically 0. Let us define this one. Okay, the count is basically 0, and that is something what we are trying to figure out. So whenever the value 0 is we may get from this particular array, we will try to see whether the target is basically greater than or equals to 0. If it is greater than or equals to 0, we will consider entire array's length, because in total when we multiply 0 with all these array numbers, it is going to be 0. So it is like count is basically got incremented with n2. So count, whatever the count previously that we have, we will add this n2, that is like 4. In total 4 products we will get which is equals to 0. And if let us suppose target is like 12, below this 12, below this 12 we are basically trying to figure out how many total products which is having answer less than or equals to this 12. That is something what the question for us, right? So based on the count only we will check whether the count is basically less than this 6 or whether the count is basically greater than this 6. Based on that we will actually modify this our answers range. Okay, that was the basic idea for us, right? So yes, below this, if this target is basically greater than or equals to 0, definitely entire nums to length we will consider. Okay, in the count we can add it. So for 0, the idea is simple. If the target is basically greater than or equals to 0, we will consider the entire nums to length in the count. Okay, now if the nums from this number one, okay, nums one from this array, first array, if the number is actually positive. Okay, in positive case, okay, in positive case, for the 0th case we already got to know that target should be greater than or equals to 0, then only we will consider it, otherwise the value is basically 0. It is not necessary to consider all of them, right? So let us suppose answer is basically right in the negative range. Okay, in the negative range the answer is basically lying. and this basically whenever we multiply it with 0, it is basically 0. So our concern is basically lying in this range, and whatever the product that we are getting is basically 0 at 0. So definitely this is the count we are not considering. Okay, so that should be avoidable. Okay, so we will simply ignore all the counts basically equals to 0 in that case. If the answer is basically negative, the answer is basically relying in the negative range. Okay, so yes, that is for the 0. Now for the positive. Okay, for the positive we will try to see. So here the 4 is basically a positive number. Okay, we are basically traversing into this array, and each element we are trying to multiply with these numbers. Okay, and for multiplying we will apply binary search. That is pretty much easy. We will see like how we can apply it. Let us try to see for the positive number. Okay, for the positive numbers we will try to apply the binary search. Let us see that when I multiply 4 with any negative number. Okay, when we multiply 4 with any negative numbers, the answer is basically negative, correct? So if we multiply 4 with the minus 3, it is minus 12. If we multiply 4 with minus 2, it is going to be minus 8. When we multiply with positive number, it is going to be positive. Now the positive number, when we started multiplying, the answer is basically getting increased. When we multiply with negative number, the basically answer is getting decreased. Okay, so the target value is 0. Target value is basically 0. So the first thing that we will do is we will apply binary search on this one. Okay, this nums2, whatever the nums2 that we have, apply binary search. With the help of binary search, we will try to see how many numbers we have to consider from this one. Okay, from this nums2, how many numbers basically we have to consider. Okay, how to do that? First thing is, whatever the number that we have, let us suppose we are discussing about a positive number. So let us suppose we traversed entire array and we reached at this location, fourth location. Okay, whatever the value that is there. So 4 is the value that we have. So we simply get the medium of the midpoint of this nums2. Okay, the midpoint of this nums2 is like 0 plus 3 divided by 2 is basically 1. So this is the midpoint. Minus 2 is going to be the midpoint. So what we will do is we will simply try to multiply it with that. This current number, whatever the current number that we have, we will simply multiply with the mid of this nums2. Okay, so the answer is negative, minus 8. Okay, whatever the answer it may be. Okay, it could be positive value as well. But the target, comparing with this target, this answer, whatever the answer that we are getting right over here, is it satisfiable? Because whatever the answer that we have, we are basically trying to get the counts, total counts below this 0 or equals to the 0. Minus 8 is basically lying here somewhere in this range, negative side. Okay, here in negative side, the minus 8 is some line which is basically less than this 0. Okay, so this is acceptable. The moment we realize that, okay, this particular value, whatever we are getting, it is getting accepted. So in that case, let us suppose two pointers we are applying. Here it is a low, here it is a high. This low should be pointing here because this answer is basically satisfying. So whatever the mid that we got, mid plus 1, the low should be started pointing. Okay. Okay. Now here the question is why? Why this L low range should point mid plus 1, right? Because see, this number is 4, and when we multiply 4 with any lower numbers below this, definitely the array is basically sorted order. So if we try to multiply this 4 with any number less than this minus 2, definitely it doesn't matter if it is a minus or positive. We are only considering these numbers which are actually in this range. Okay, so if it is value is 0, if it is a positive number or a negative number. So any number when we multiply this, whatever the value that we have, when we multiply this with the array's second product's array's mid value, if the value is basically less than this target value, whatever the target we have decided, if it is less than this or equals to this, definitely previous values, all the previous values will definitely less than or equals to this value, correct? Because if this is satisfying, this value whenever we multiply lower, whenever we start going in the lower direction, obviously the multiplication is basically less than or equals to this target. So yes, low should now point to mid plus 1 because all these values we can consider. Okay, all the counts, whatever the counts 1 to these values we can consider in our answers list. Okay, so yes, basically we are trying to get the counts only, right? So yes, these values are in working condition for us. Okay, so L should be now pointing to mid plus 1. Okay, now in new range we will try to see in this new range from 1 to 4. Okay, high is basically pointing to 4 and low is basically pointing to this one. The mid is something what we will try to figure out. Okay, because we are applying the binary search and we will keep on doing it until and unless whatever the product that we are getting with this number, if it is going beyond this, Okay, if it is going beyond this, the high can be now continue pointing to mid minus 1. Okay, that way we will apply the logic, and until and unless low basically goes beyond this high, we will keep on doing this operation. Okay, now in this particular range 1 to 4, the mid is basically 1. Okay, so mid, the moment we got 1, we will try to multiply this. So 4 into 1 is basically 4, and we got to know that okay, now 4 is basically greater than this 0. Okay, the target is 0, but the 4 is actually greater than this 4. So yes, this is going beyond the range, and we are trying to see how many products that are there less than or equal to this 0. Okay, so 4 is going out of bound, so yes, the high should now point to mid minus 1. Okay, so mid is basically pointing to this, so high basically points starting point here. Okay, high basically started point right at this location. So now the moment we see that low is basically greater than the high, we will break out of it. So wherever the low is basically pointing, wherever the low is pointing, below this, below this low, all the total counts that are there, that are acceptable for us, correct? Because the length is basically n2 for this one. N2 minus this low. N2 is basically 4. Low is basically pointing to this, it is 0 based indexing. So 0, 1, 2. So low is pointing to 2. Okay, so the answer is 2. So two numbers that are there, we are just trying to figure out how many numbers. Okay, we are not multiplying entirely, we are just multiplying with the mid, and based on the mid, we are using the, with the help of binary search, we are checking that whether this product whatever we are getting, if it is less than the target or greater than the target. If it is greater than the target, definitely high should point to mid minus 1. If it is less than the target, of course, till that point all the answers are satisfiable. Now we will try to see if any further elements that are there which we can consider. Okay, so low is basically pointing to mid minus 1, mid plus 1. Okay, that way we will apply the logic. So if the whatever the target that we have, if the product that we are getting when we are doing this product with this any numbers from this array, if it is actually greater than or sorry, if it is less than or equals to the target, if less than or equals to target, low basically updates to mid plus 1 in this case, or else in the else condition high is basically pointing to mid minus 1, and this will keep on doing it until low is actually going beyond this high. Okay, and whatever the low basically where it is pointing, that is going to be the last value. Okay, so the range that we can get is like from this 0th index to the length. Okay, so we are not supposed to subtract these values. Okay, it is whatever the length that we are getting so far from 0th index wherever the L is pointing, till that point the entire array's values are satisfiable for us. Okay, so it is like it is pointing to second index, so that means like 0, 1, all these values are satisfying. So yes, two values are basically satisfying for us. Okay, wherever the low is basically pointing, that is going to be beyond us our scope. Okay, so yes, it is like exclusive range. So yes, so wherever the low is basically pointing, we can consider till that one. So since we are starting with the 0 index, so yes, so whatever the value that we are getting for the low, total those counts we are getting it when we multiply this. So yes, this loop is keep on going on from this n1 array, nums1 array, and we are keep on checking how many counts that we can get it with the help of this particular number. Okay, we are checking based on these conditions. If it is 0, if it is whatever the value that we get, okay, the target that we have, if it is actually greater than or equals to 0, we will consider entirely. If it is a positive one, we will check this. If target is actually less than or equals to 0, then low basically points to higher elements. Now it comes when the negative elements that are there. Okay, so 4 minus 4 is basically the negative element. Okay, we are basically starting from the 0th index, because in a case of like 0 and 1 I explained those cases. Now if the number is negative from this num1, in that case reverse is what happens, because whenever we multiply any number, negative number, with any positive number, the value is basically getting decreased. Minus 8 is something what we will get if we multiply with a positive number from this array. Okay, so yes, if value is basically getting decreased, that means the answer will be basically lying in the targets. Okay, what I'm trying to say, let us just try to focus again. So here we have minus 4, the mid is basically from here. Again we will try to see the mid. Okay, it is pretty much straightforward. Now see, the mid is basically minus 2. Okay, here minus 2 is there, the mid basically we get is minus 2 again. So what we do, 4 into minus 2 is what we will do, it is basically 12. So 12 is actually greater than 0. Okay, whatever the mid that we are getting, if value is actually greater than the target value, of course when we go in the downside, okay, when we go in the downside, okay, minus 3 if we multiply, or any value we keep on multiplying, these values are basically going to be greater than the target, because this way the answer keep on increasing. Okay, this way, if we start moving in this way, whenever any negative number that we get, if we start multiplying them this way, in this direction, the answer keep on getting increased. Okay, so that is something what we have to consider for the negative number. So here, if the target value, whatever the target value that we have decided, if when we multiply it with mid, if it is getting increased greater than this zero value, of course now whatever the low that we are pointing, it should point to mid plus 1. Okay, it should point to mid plus 1. Here we are just doing reverse operation. Okay, so because in the negative number, the target keep on whenever we moving in this left right to left direction, the target basically start increasing whenever we multiply it. Okay, at any point in time when we notice that when we multiply these values, okay, when we multiply these values, and it is basically less than the target value. Okay, where it happens when the now the low is basically pointing here. Okay, high is basically pointing to 4, the mid is basically 1. Okay, so when we multiply minus 4 into 1, minus 4 into 1, the answer is minus 4. Negative 4 is what we will get. So negative 4 is actually less than or equals to this target value. Okay, so here we got to know that, okay, negative 4 is basically less than this target value. So the high should now point, okay, this high, whatever the high that we are pointing to the last index, okay, that should start pointing to mid minus 1. Now here we have the very less range, so it is basically acceptable, but we are trying to shrink in the opposite direction for this one, negative values. Okay, so yes, this way we will keep on trying to see if how many numbers that are there below or equals to this whatever the target that we have set. For this first it is 0. Now total counts, how many counts that we get, we will simply check with the k value. Okay, we will simply check with the k value. If this whatever the k value that we have, 6 is something what we have, and I already explained total counts for 0, we will keep on collecting them, and if total count is basically greater than this k value, the range should be shrunken again. So we have to check in this one. So wherever the high basically pointing previously, it was pointing to 16, it should start pointing to 0 minus 1, whatever the value that it gets. Okay, now the range got shrink again. In this particular range we will try to get the mid. Same operation we will do if the total counts that we got for this target value 0, if it is less than this k value, the low should point to 0 plus 1. In that range only the answer basically relies. At any point in time we got the answer, it is going to be the value. Okay, so yes, that's how this algorithm works. Let me start writing the code first, and the moment I write down the code, I'll again with the help of example, I'll explain you guys if still faces issues understanding this particular algorithm. And yes, the at with the second example, I guess you guys will get the idea about it. So if you got the algorithm, you can start writing the code, or else stay with me. I'll keep on writing, and with the help of writing the code also, I'll keep on explaining you guys. Okay. So yeah, now the first thing that we basically saw in the algorithm while discussing the logic is we have to get the minimum range as well as the maximum range of the product. Okay. So to get the minimum range and maximum range from the product, we can get minimum value and maximum value, and again get the range. But instead of doing that, what we can do is basically this numbers range is relying from minus 10 to the power of 5 to 10 to the power of 5. Okay, this is the range that it is been given, and when we multiply this minus 10 to the power of 5 two times, okay, let us suppose nums 1 has a lowest value, that is minus 10 to the power of 5. Even in nums 2, it has the 10 to minus 10 to the power of 5 is the value that we have. So the lowest minimum that we can get is, we will decide here. So low is basically 10 to minus 10 to the 5 into minus 10 to the 5 is basically 10 to the power of 10. Okay, so 10 times I will add here 0. That is the lowest range that we can get it, and it is pretty much big, so we have to use long obviously right over here. The high is basically again same. Let me just copy, let me paste right over here. Here it should be negative. So this range is going to be acceptable for all the whatever the valid inputs that we have. Okay, basically we are not going entirely, even if we have smallest arrays, we will squeeze our range and we will keep on getting the answer. Okay, yes, this is acceptable. So now we will try to get the answer. Okay, let me create here, let's write binary search logic. Low should be less than equals to high. Let's get the mid. It should be low plus high minus low divided by 2. Okay, This is the target value. Okay, mid is basically the target, so we will keep on checking if whatever the product that we are getting, if it is less than or equals to this target. Okay, the first thing is like we will check if count pairs. Let me write this function. Okay, in this one we will pass this target, we will pass the nums1, nums2. Okay, and if it is less than this k value, okay, whatever the count pairs, if it is less than this k value, okay, this basically returns how many total counts that are there which is having products less than or equals to this mid value. Okay, based on that value, what we will do is, if it is less than this k, that means the range should be extendable. Below this 0 we are getting some, let us suppose 7 counts, and k value is basically 8. So yes, we have to increase our range. So low basically start pointing to mid plus 1. If not, in the else case, what we will do, high basically start pointing to mid. Okay, if not, that means if it is equals to k as well, if that is the case, there could be many multiple pairs which are basically equals to k, and that is something what we have to figure out. So yes, mid is basically high basically points, it is not pointing to mid minus 1. Okay, that could be answer at last. Okay, whatever the high basically it is pointing, it could be answer, but there could be multiple pairs who is having counts same of this mid. Okay, so high is basically pointing to mid minus mid basically. Okay, and at the end wherever the low is pointing, that is the answer that we will be having. Okay, so yes, if you guys are basically struggling with binary search application, like how we are using low high, okay, I'll create a video if you guys are struggling. We with that one we will get to know like how instantly we can decide whether this low is basically pointing to this one and this one. Okay, while deciding the range, few times we may end up having trouble and we write differently. So here it is basically returning pairs. So it is private long. Let me write down this count pairs. Okay, in this one the first argument is target. The second is like nums1. Okay, and the third one is like nums2. Okay, this is the array. These are the values that we are having with us. So let's get their length. N1 equals to nums1 dot length, and N2 equals to nums2 dot length. Okay, and long count is the count that we will be having. That is something what we will return. So how many pairs that we got? Okay, that is for this count. Okay, so first thing that we will do is we will traverse through any one of the array. So let me traverse to num1, and see, it is required to traverse any one of the array, because we cannot apply binary search on both the arrays, okay, simultaneously. There could be values which are basically negative, positive. We might be missing them, okay, while doing any operations like that. Yes, any one of the array we can traverse, and with the help of this array, whatever the value that we are getting, based on that, we will decide the range, okay. So if this, let me writing instead of this, we have to keep on doing that. Int num basically from nums1, if this num basically if it is equals to 0, that is the first condition. We have to see that if the target value is basically whatever the target value that we are getting, if it is greater than or equals to 0, we have to consider entire array's length of nums2, because whenever we multiply 0 with any numbers, it is going to be 0. So we have to consider all the elements that are there from nums2. Okay, so that is the first condition. if this num if this num is basically greater than 0, okay, that means it is a positive number. So in that case, let us start applying the binary search. Let's decide low here for from the nums2. So it is basically pointing to 0. High is basically pointing to n minus 1, n2 minus 1. Okay, we got low and high. Now the question is, let's apply the binary search and get the range. Low basically less than or equals to high. Okay, till then we will keep on checking. So let's get the product, whatever the product that we are getting. Let me name it as a prod, and we have to convert that. So what is that value? This num from the array first into this mid. Okay, we have to get the mid. Okay, mid is basically low plus high minus low, divide by 2. Okay, mid we got. Okay, the moment we got this mid, we have to get that numbers from nums2. Okay, nums2, what I'll do is I'll paste here nums, and mid is something what I'll get. Whatever the product that we are getting, we will check whether this product is basically greater than a target. If this product is less than target value, Okay, if it is less than the target value, we simply increment the low equals to mid plus 1. Okay, because the number is positive, so below this all the values we can simply consider, or else in the else condition what we can do is high should points to mid minus 1, mid minus 1. Okay, but here the problem is the target should be product, whatever the product that we are getting, it should be less than or equals to target. Because see, if it is equals to the target, okay, so that number should be considered. Okay, that number should be considered, and we are actually whatever, wherever the low is basically pointing, those many numbers we are considering. Okay, so that is the simple logic we will apply now. Whatever the low, wherever it is pointing, based on the ranges, we will get the answer. So the answer is like in the count, whatever the count previously that we have, in this count we will add all the numbers. Okay, wherever the low is pointing, below that entire numbers are basically considerable, because when we multiplied all those, we are getting the product less than or equals to the target one. Okay, so wherever the low is basically pointing, that is the answer. If at any point in time when we multiplied an entire array is basically not giving us the answer, so low is basically pointing to 0, the high is basically keep on decreasing. Whenever the high basically goes beyond the low, we will break from it, and low at that moment low is basically pointing to 0. So yes, the 0 values are basically we are considering. Now there is another case else, if number is actually greater than 0. Okay, this num value whatever we have, if it is greater than 0, we will use the same code right over here, but simple modification, slight modification is something what we have to do. Low is basically pointing to 0, high is basically n minus 2, n2 minus 1. Okay, n2 is the value of this nums2 dot length. Okay, the mid we again get the same, product is same. Now here product if less than the target. Okay, if the product is actually whatever the product that we are getting, if it is less than the target, that means we have to shift our high. Okay, so wherever the high basically pointing high, it should start pointing to it should start pointing to mid minus 1, or else low should start pointing to mid plus 1. Okay, the reverse logic is something what we will apply right over here. Yeah, that's it. Now what we can do is we can simply return the counts based on how many counts that we got. We will compare it with this k value. If it is whatever the count that we got, if it is less than this k, low should points start pointing to higher ranges. Okay, this mid basically is the basically the target value. Okay, this is the range of the products. In between that range the answer basically relies. Yes, so wherever the mid points at any point in time, if it is equals to k, definitely that is going to be the answer. Okay, this way we can write down the code. Let me try to run the code. Let's see if we have any issues. Okay, there is an error, line number 7. What it is saying, it should be long, right? Okay, we are passing here that it is not the target, is should be long. And what else I'm missing? Nothing, right? So let's try to run and see if it is working fine. Okay, case 2, case 3 are getting failed. So why they are getting failed? The output is basically pretty much big. The expected answer is 0. Let's see where we went wrong. So do we have 0, 1, 2, 3, 4, 7, 8? Okay, this is fine. Now low is basically pointing to high, and mid is something what we got. Count pairs, we if it is less than k, low is basically pointing to mid plus 1, because obviously we have to do that. For this high, then we are getting low. In the count pairs, the first thing that we check is if nums is actually okay. If it is 0, the target should be greater than or equals to 0. Then in the count we will consider entire n2. Okay, whatever the range that we have. So in the else case, if it is greater than 0, it is a positive number. So we got low high. When this mid is something what we will try to see, the product is what we are getting, num into nums2 of mid. Now the product, whatever the product that we got, it should be, if it is the product that we got is, if it is less than or equals to the target. Okay, target is, let us suppose 7 is the target that we have, and product what we got is 4. Obviously this product that we got, we should go higher end again. Low should point to high, mid plus 1 is where the low is pointing now, and else low is pointing to mid minus 1. Okay, in the else case we are actually getting the same values, low is pointing, but here it should be in reverse condition. Whatever the low it is pointing, let us suppose product is 7, target is actually 8. Okay, so if it is less, the high should point to mid minus 1. Okay, the high should point to mid minus 1. If product, let us suppose product is basically 7 is something what we got, and the target is big, wherever the mid pointing below that whatever the range that we are getting, that should be, it should be squeezable. Now low is pointing to mid plus 1, but here in the count I made a wrong answer here. See, let me correct right over here why the count should be updated in different ways. Okay, so let us suppose we have this values. Okay, -4 is the value that we have, and we are supposed to get the range from this array. Okay, -4, -2, 0, 3 and 2. Okay, and the target value, let us suppose target is basically let us suppose minus -1 is the target that we have. So when we start multiplying it, so mid is basically from here, the mid is basically 0. So when we multiply -4 with the 0, the answer is basically 0. Okay, so we will compare it with the target. So -1 is the target that we have. Okay, currently let me take that values as well. Low is basically pointing to 0, high is basically pointing to this length -1, it is basically 4. Okay, sorry, it is basically 4, right? So yes, now this product is basically 0 and target is -1. We are checking right over here, whatever the product that we got, product is 0. Is it less than this target? No, it is not. So our low should start pointing to mid plus 1. So it was initially pointing to 0. Now mid was basically in the earlier, it was like second index, it was pointing. Mid is basically now start pointing to 3, because this product, whatever the product that we got, 0 is the product that we got for when we multiplied -4 with the 0. So obviously when we start multiplying below this, answer is basically going to be greater than this target value. Okay, that is going to happen for sure. So yes, we have to decrease our range. Okay, so what we will do in this particular case, high, wherever the high is basically pointing, sorry, low is basically pointing, because we are not entering into this condition, we are entering into else condition. Okay, because this product is basically greater than the target, so low should point to mid plus 1. So low is now basically pointing to 2, plus 1 is basically 3, high is basically at 4. And now with this high and low, the mid, whatever the mid we will try to figure out, it is going to be it is going to be 3. Okay, 3 is the mid. Now mid is basically we got, so with this mid we will again try to get the product. So product is basically this 3 into -4, it is going to be -12. Okay, -12 is something what we will get. Okay, the moment we get this -12, okay, it is basically less than this target value. Okay, so if that is the case, definitely we will enter into the if condition. So high, wherever the high basically pointing, we will try to squeeze its length. Okay, so high was basically pointing to 4, the high will be pointing to, low is basically pointing to 3, high will point to mid -1. So it is basically going to be mid was basically pointing to 3, so high is basically 2. The moment low and high basically happens, we will break. So now the low is basically pointing to 3. Okay, the third index is where sorry, this third index is where we got the answer. Okay, it was satisfiable, and from this third till the end, all the ranges values are basically satisfiable. But again, we have to make sure that whatever the range that we are deciding, it should be appropriate. Okay, it might be again the range could be squeezable and all. So this low is basically pointing to this one. Okay, third index. So below this, all the values basically are not satisfiable. So the count should be wherever the low is basically pointing. Okay, n minus this low. So this is the range that we are considering, right? So n minus this low, wherever the answer that we are getting, that is the satisfiable answer. Okay, so what we will do is, in this case, after the while loop, the count where it was pointing, count equals to count plus n2 minus low. Okay, that is something what we have to do. N2 minus 2, if we do, this is the value that we get. Low is pointing to this one, and the entire range is n2, so it is 5. If 5 minus 3 is what we do, two values are basically satisfiable. Okay, so that's why count basically points to in this fashion. Okay, so this way we can do it. Okay, now I think that should be the issue, because I don't think there are any further issues. Let's try to run this one. It is acceptable. Let us try to submit the code as well. So in this particular code, if we talk about the complexity, so this particular, whatever the while loop that we are running, this is basically taking it is a binary search. So let us suppose whatever the high value that we got and low value that we got, so it is going to be obviously taking log of whatever the range that we got, right? So product range. Okay, so that is the complexity for this one. And again this count pairs where basically we are doing each time we are going to this nums1 length. Okay, nums1. So in this one we can again optimize it. Okay, how we can optimize it? Whichever the length range nums1 or nums2, whichever having smaller range, that we can pick as an array. Okay, that we can pick as an array, because we will traverse through that, and whatever the nums of length having the having it is having most of the elements. Okay, if that range is actually big, we can apply binary search on that one. Okay, that way we can at least try to reduce this complexity, because we are not sure that if nums1 or nums2 is having most elements. Okay, that way also we can squeeze the complexity. So log n, whatever the range that we have, into this arrays keep on traversing every time. So let us suppose nums1 having n, so log m cross n cross, again we are applying the binary search logic. Okay, so that's how the complexity is basically working. So whatever the this n2 we have, so log of n2, that way the complexity happens right over here. We are not storing anywhere any elements. So yes, whatever the answer that we get, that is the answer. Yes, we can further improve it. I actually place redundant code. We can omit this and we can merge this both of them in one single loop as well. So that way also we can optimize the code further in terms of readability. So yes, that's all from this particular video. And just do let me know if still you guys are struggling. I thought of explaining it this code further again with the help of another example, but actually it is the laptop is lagging a bit. If you guys still struggling to understand this particular code, do let me know. I'll make sure to upload another video for guys who are basically struggling to understand, because the moment you understand this particular code, most of the binary search codes will be pretty much easy for you guys. Okay, you can solve any kind of binary search codes with the help of this one, because there are multiple ways we can apply the binary search, but we should get the instinct like how the binary search logic should work and how it should basically apply, so that we will not get any errors while writing the code. Okay, because in range we might faces issues. Okay, so yeah, that's all from this particular video. I hope you guys understood this, and thank you for watching this one. Bye bye.